Hello there, this is exercise 14D for year 13 maths. This is one of those topics for chapter 14 and 15 which are all about numerical methods, and this particular method is called fixed point iteration. And we tend to do fixed point iteration on, and these by the way are both examples or graphical interpretations of fixed point iterations. And we tend to do it when other methods don't work. So for instance, Newton-Raphson might not work. Now you might recall that in order to solve Newton-Raphson we had to do some differentiation, and it allowed us to solve equations of the form f of x equals 0. That's what this says here. It says we are trying to solve equations of the form f of x equals 0, and what that basically means is you've got a graph and we're trying to find the points where it crosses the x-axis. That's the 0 line, if you like, and that's what Newton-Raphson is very good at. But a fixed point iteration, we have to rearrange the equation, and there is a reason for that, and I suppose it's the graphical bits I talked about just now on the last slide. We have to rearrange it into this form, and it's always quite easy to do a rearrangement like that. But one of the issues is there's more than one type. So we rearrange the equation into the form x equals g of x. Now for instance, you might have an equation which is, I don't know, x equals or x plus sine x minus 2. I have no idea what that looks like, I've just made it up. But what you do in order to find if there were any solutions, and I'm not convinced there were, you could, for instance, move the sine x and the 2 onto the other side, and you'd have x equals, well, 2 minus sine x. And you'd be like, when does x equal this line, this graph of 2 minus sine x? Or I suppose instead of that, we could move the sine x onto its side onto its own, and that would be equal to 2 minus x. The only problem with this is it doesn't say x equals, so then I could take x is equal to the inverse sine of 2 minus x, whatever that might be. The point I'm making, of course, is there's more than one possible rearrangement. In this PowerPoint, the good news is the rearrangement is done for you. In due course, we have to decide what rearrangement we want to do. So this method then basically finds successive values, and this red line in both pictures, if you just look at this red line says y equals x. This is my y equals x line. And this g of x, well, in that last example which I had, I can't remember what I wrote now, so let's just see what I wrote. Oh, well, I wrote x plus sine x minus 2. So I had y equal x plus sine x minus 2. And what I tried to do was rearrange it. I said when's it equal to 0, and my first interpretation was x would be equal to 2 minus sine x. So I suppose what this is, that's one side, this is the other side. This would be your g of x, your 2 minus sine x part of it. And so when I draw this blue line, having had a y equal f of x scenario, I rewrite it as x equals g of x. And I try to find where those two lines cross. It will be the same place as the other one would have crossed. And if my first example is, which I'm going to call x1, the idea is it goes up to the curve. That value effectively allows me to choose an alternate x2 value. So this is x2 now down here. You go up to the curve, it come across, and it allows me to find another one, x3. And if you've chosen wisely, bit by bit by bit, it gets closer and closer to the actual answer, which we're going to call alpha. That's what we would describe as a staircase diagram. There are alternatives, and the alternatives, one of them, which works, is called a cobweb diagram. And you can see why it looks like a cobweb diagram. It's where you'll notice this blue line now, this g of x is actually sloping downwards rather than upwards. And so my x1 goes up into the function, up to the curve, and when I get my next value, it's over here, x2. So I go, okay, then I'll try that one, and then it gives me this one here, x3. And you'll notice it kind of jumps backwards and forwards and homes in on it by sort of either side, dun 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 dun. And bit by bit, it will get closer and closer and closer to the actual answer. That's the idea. That's why it looks like a cobweb. Notice my wording here, curve to line, curve to line. That's the way I'm going to talk about this. You start with your point, and you go into your curve, across to your line, into your curve, across to your line. On this one as well, you go up to the curve, across to the line, to the curve, to the line, to the curve. But notice it starts on the curve. It is known that equation x equals log x plus 3 has a solution between 4 and 5. And it says use fixed point iteration. Well, look here. The good news is it has been rearranged. Notice it doesn't say it's equal to 0 and we get asked to rearrange it. We just put this in. Now, this effectively becomes an iterative process. This becomes xn plus 1, this becomes xn. So if x1 equals 4.5, which it tells me to do, my x2 I can do on my calculator, and it's the log of 4.5, add 3. And we've seen how to do this in the past, haven't we? We've seen in the past, you type in 4.5 and equals on your calculator. And by pressing the equals button then, I can then say xn effectively, which is what I want to find. I'm going to type into my calculator, well, it says log of, so I do log of the answer, plus 3, and then press equals. And then you get the advantage of this is it, my last answer becomes my new answer. And I can just do this until I get the answer I want. So menu 1, I'm going to type the 4.5 in, and then I do the log, natural log of the answer, close bracket, add 3, equals. And I get 4.504. In fact, it's very close to what I had in my initial guess. So what's that? 4.504. And it wants it to 5 significant figures, crikey. The 5041, okay, so what does x3 equal? Well, I'm not going to type it out every time. By this time I get 4.50498, 50. Press it again. Well, no, it has changed. X4. Oh, it says up here gives the next 4 approximations, okay. This one's 4.5052. Ah, that's why it said that, because after that many goes, it's the same answer, 5052. Show that the solution is correct to 2 decimal places. Well, I suppose that's, well, we can use a variety of methods. One, of course, that we saw in the exercise 19a was called the change of sign method. So I suppose to 2 decimal places, we'd call this 4.51. So using that as my answer, what I suppose I'm looking for is to say that this is correct. So it will be, if I go a little bit smaller than this, say 505, I don't know why I've done that there. If I go a little bit smaller and a little bit bigger, 4.505 and 4.515. If this is one's a change of sign, then I know that this is correct. 4.51 is correct to 2dp. So all I've got to do, my initial function, I suppose, well, it's x equals this. Now this, of course, has to be equal to 0. So I'm going to write log x plus 3, and I'm going to move that x onto the other side, because then it would be equal to 0. That's the equivalent of that equals 0. And now I reckon that if I put 4.515 in, I'll get a different sign from if I put in f of 4.505. Let's try that. So what is it? I'm going to do 4.515. And what do I have to do? I have to log that. So log of that number, close bracket, add 3, minus that number, 4.515. And I get a negative answer, minus 0.0007, and a bit, 76. I'm hoping, therefore, I get a positive on the other one. So 4.505, what do I have to do? I have to log that, natural log of that, close bracket, add 3, minus that number I just had. And this is positive, so 0.00019. So we've got a change of sign. It did happen. oops, and therefore is in between those two values. What have I got here? And that's exactly what these posh answers have done. In fact, they've rearranged it in exactly the same way as me. So there's a change of sign, therefore it is equal to 4.51. I'm not sure if you can quite see that to 2dp. The equation x equals cos x has a root between 0 and 1. Obviously this is the graph cos x. This is the graph of y equals x. Obviously this wasn't the original problem that you'd had. You would have perhaps been given initially f of x is cos x minus x. And we have rearranged that. So this is my y equals x line. And this is what they called before the g of x. And we are trying to rearrange it. Draw a graph to illustrate it. Well, it's been drawn done for me. But it says to illustrate the first three approximations. Well, it says initially use x equals 0.5. So that's around there. So let's just notice I go up to, and you might need to draw these in your exam, up to the curve, and then across to the line. Down to the curve. That's my second one. So that's x1. So that is x2 there, because it's in line down there. Then I go across to there and up to the curve again. Now that point there is x3. And you'll notice this is a cobweb type of diagram. So let's find the root correct to 3 decimal places. Okay, let's go for it. Effectively, x plus n plus 1, or look, it says it there, equals the cos of xn. So my first guess is x1 equals 0.5. I can just type that in. So I'm going to type in 0.5 equals. I'll do, oh, make sure you're in radians, or you didn't do that. Angle unit is in radians. Okay, I'm now in radians. So I'm going to do the cos of the answer equals. So x2 equals 0.8. It says 3 decimal places. 877. I'm going to say 6. Press it again. I get 0.6390. And look, that's an example of it jumping from one side. It goes up to there, down to 0.63. I go up to 0.8. 0.27. Down to 0.69, and after a while you get a bit bored of writing them all, so I'm going to stop now. 6948, and when I say stop, I'm going to press equals 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 equals, lots of equals, until eventually, hopefully, it doesn't change anymore. Well, it might do. I'm having to press equals a lot of time actually. 0.739 it's coming out as. So eventually, and I'm going to call this alpha. It's very common to call the root alpha, so I'm going to write 0.739 to 3dp. 0.739. Their picture looks very similar to mine. They've done exactly the same thing. And notice again, they missed out loads. They wrote down a couple. It's always best to write down a couple of answers. Sometimes it says write down every answer to 8dp, and you write everything down off your calculator. Sometimes it just says find the solution. Interestingly, they said the sequence converges to. Converges is the posh way of saying it found a root, it found an answer, got better and better and better all the time. Notice that implies sometimes it doesn't. But rather than writing alpha, they wrote just x equals, which is fine. No problem with that at all. So in class we'll do exercise 14D, that is page 316, etc. And we'll just do a whole bunch of questions from that. Thanks.